Alright, there are 213 identical plastic chips, numbered 1 through 213 in a box. What is the probability of reaching into the box and randomly drawing a chip numbered 170? Express your answer as a simplified fraction or a decimal rounded to 4 places. Okay, there's only one chip that's numbered 170. There are 213 chips. Probability equals 1 over 213. So, number 1, the probability of getting that chip numbered 170 is equal to 1 out of 213. All right. Problem number 2. Determine whether the statement describes a population or a sample. Well, let me input this answer real quick. Probably should use this keypad. Make a fraction. 1 over 213. Alright, question number 2. Well, this problem looks exactly like the last problem. Okay, there are 397 identical plastic chips numbered 1 through 397, so at first it does anyway. But then it says, what is the probability of reaching into the box and randomly drawing a chip that is greater than 325? So you need to know how many chips would be greater than 325 if you have 397. Alright, so what's 397 minus 325? That's 72. So the probability is going to be 72 over 397, the total. I don't think that will simplify. Alright, bank account numbers. This is talking about the bank account numbers are what type of data? Statistic, qualitative, inferential, or quantitative? So which one do you think it is? Quantitative. So if I take your bank account number and I subtract that from my bank account number, the number that I get, do you think it'll have some type of meaning, or is it more of a label? Is a bank account number more of a label than it is like a quantity? So since it is like more of a label, it is qualitative. That's kind of tricky because you see the word numbers and you start thinking, well, something I can do with numbers, quantity, and then, yeah, that's all bank account numbers are. They're just labels. That was qualitative. All right, determine if the correlation between two given variables is likely to be positive or negative, or if they are not likely to display a linear relationship. The average selling price of a model of a car and the cost of a loaf of bread on a given day. Alright, so you think those two are related? No. So what would that mean? That would mean there is no correlation. Select the graph that best illustrates the following distribution shape. Uniform. Uniform means roughly the same all the way across. This one here. Uniform. Alright, identify the sample chosen for the study. The types of cars of a sample of 26 parents of your classmates. So would it be the 26 parents? All parents? Or the types of cars of the entire population of the U.S.? So identify the sample. Parents. I mean, you could say, well, it's the cars, but each car is related back to a parent, right? So, parent. All right. Thompson & Thompson is a steel bolts manufacturing company. Their current steel bolts have a mean diameter of 134 millimeters and a variance of 49. If a random sample of 47 steel bolts is selected, what is the probability that the sample mean would be greater than 136.2 millimeters? Round your answer to 4 decimal places. Okay. So I'm going to need that mean, that variance. What number are we on? Already? So we need the mean, we have the variance, I think it's the population variance they gave us. 134 and a variance of 49. If a random sample of 47 steel bolts is selected, what is the probability that the sample mean will be greater than 136.2? So we're going to know the probability that x bar is greater than 136.2. Yeah, I think I wrote down the mean wrong. 134, thank you. And then we had 47 steel bolts selected. So that's our n, 47. So it looks like this is a central limit theorem problem where you're selecting multiple items, and you want to know if their mean, the probability that their mean is greater than a certain value. Alright, so we need to find a z-score. It's going to be x bar, or the data item we're looking at, this one, minus mu, over, usually it's just sigma. Sigma is the square root of 49, so it's 7. But remember, it's what? Sigma divided by the square root of n. So, I mean, that formula is it's x bar minus mu, but because we're talking about means, it's usually just an x value, over sigma divided by the square root of n. That's what our z value is equal to. All right. All right, so punch this in your calculator, whichever way makes sense to you. Whenever I'm doing this in this little Windows calculator, I flip and multiply the denominator. So I say it times the square root of 47. So times 47 square root equals, and then I divide by 7. All right, so z-scores around 2 decimal places. So that's 2.15. 2.15, and I want to know the probability of it being greater than. And that makes a difference because when I go to my tables, I want the area to the right if it's greater than. So I'm going to look at table C here. And if I want the area to the right, I have to say 1 minus the area that it gives me. So 2.15, I have 0.9842. So it's 1 minus 0.9842. That's the probability that the mean is going to be greater than 136.2. The mean of those 47 selected items. Right. So that's going to be 0.0158. Alright, a coin is tossed 7 times. What is the probability of getting at least 1 head? Bet it's pretty high. Just think about it common sense wise. Remember, at least 1, there's a shortcut you can use. The probability that x is greater than or equal to 1, where x is the number of heads, that would be at least 1. That's equal to 1 minus the probability of none. It would be 0 heads. So the reason I say that is because you don't want to use, you have to use the binomial probability distribution formula, and you don't want to have to work out that for x equals 1, x equals 2, x equals 3, all the way up to 7, and then add them all together. So, let's see. The number of trials was 7. The probability of a success, a P, a success, is 0.5, since it's a coin. And then x, for us, x is going to be equal to 0. So we need our binomial probability distribution formula. That is like chapter 6, 5, 6, somewhere around there. Alright, so our formula is, there's a combination, straight off the formula sheet, probability that capital X equals little x, so we have x equals 0. So it's equal to the combination times success to the x times 1 minus success to the n minus x. Okay? So it's going to be 7 factorial over, what's that going to be, if I remember? 7 minus 0 factorial times 0 factorial times 0.5 to the 0, and then 1 minus b, that's going to be 0.5 to the what? N minus x. So that's 7. Alright? I'm fine with that. That's good to me. 7 factorial divided by 7 factorial is 1. 0.5 to the 0 is 1. And then, so you got to do 0.5 to the 7. Alright, so that's just going to be 1 times 1 times 0.5 raised to the 7. 0.0078125. So that is what I need to subtract from 1 to get my probability. 1 minus 0.0078125. Well, like this. We'll make it negative and add 1. Alright, 0.9921875. It says round to 4 decimal places. So 0.99, then what was it? 2. We're going to round to what? 2. That's right. I didn't have it in front of me. Let's see. Yeah. Rounding to 4 decimal places. So 0.9922. Determine whether the statement describes a population or a sample. The types of cars of all the professors at a local college. So what's that going to be? Population. It says all. Suppose 40% of politicians are lawyers. If a random sample of size 781 is selected, what is the probability that the proportion of the sampled politicians who are lawyers will be less than 43%? Round your answer to 4 decimal places. Alright, so here's what we suppose. Here's what we're looking for. Let me write these down. And these are all proportions. So P is equal to 0.4. P hat is equal to 0.43. And then the random sample size was 781. N equals 781. Alright. So this is more than likely from chapter 8 or 9, I would imagine. So if we have proportions, what do we have? So the variance is going to be equal to what? They're going to be 0.4 times 1 minus 0.4 divided by 781. So that is whatever that's equal to. You want to take the square root of it so that you can get the standard deviation. I got 0.017529927. So we want to know probability that the proportion of sample politicians lawyers is less than 43%. Okay. Less than 43%. So Z equals 0.43 minus 0.4 over 0.017529927. I'm probably taking that out a little too far, but whatever. got a z-score of 1.71. So let me go to my tables again. Table C. And I got 0.9564. When you look this up in the z-score chart, it's going to give you the area cumulative left to right. So, and we wanted to know less than 43%. So that's what we actually want. So when we look that up, that's our answer. 0.9564. 9564. All right, determine whether the statement describes a population or a sample. The heights of 5 out of the 33 pepper plants at Mr. Leonardo's greenhouse. So would that be a sample? The heights of 5 of those would be a sample. That's right. You're just taking 5 out of the 33. Decide if the following probability is classical, relative frequency, or subjective. You guess there is a 45% chance you'll be assigned homework in your statistics class on Wednesday. Fact. No, that's subjective. The following bar graph represents the number of dogs and cats treated by a local vet during 1 week. Were there more dogs or cats treated during the week? It appears cats, right? Because it looks like well, look at this side-by-side bar graph. Aha! But it's kind of tricky there. You need to add them up. So 5 and 4 is 9, and 4 is 13, and 2 is 15. 16 dogs. We got 6 and 1 is 7, and 3 is 10, and 4 is 14, and 3 17 cats. Meow, 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 meow. Some more cats. Step 2. On which day was the greatest total number of cats and dogs treated? We can tell that by just looking at this bar graph, because I mean, this shows you a sum of the two, right? So 11 were on Monday. Consider the following frequency table representing the distribution of hours students watch TV in a week. Determine the lower class boundary for the second class. Alright, so here's the second class. Remember, the boundaries are, if you take the difference between any consecutive upper and lower class boundary, divide that by 2, and then add or subtract that from an upper or lower class boundary, then you can get the boundary there. Or lower class limit is what I meant to say. So if you add, see there's a difference of 1 between these two. Divide that by 2, that's 0.5. So if you add 0.5, you can get the upper class boundary. If you subtract 0.5, you can get the lower class boundary. So the lower class boundary is going to be 18.5. So we have 19 right here. 18.5. Determine the upper class boundaries for the fourth class. 1, 2, 3, 4. So what would the upper class boundary be? 45.5. Very good. Determine the mean. So add these numbers together. And divide by 6. What did you get? 1. Determine the median. Well, we need to sort the data items for the median. So that is -9, -4, -1, 4, 5, 11. We don't have a middle term, so we add those two together and divide by 2. So that's going to be 3 divided by 2, or 1.5. 3 halves, 0.5. Or 3 halves or 1.5. Alright, so is there a mode? No. No mode. For marble, let's see, a box contains 95 red marbles, 29 white marbles, and 85 blue marbles. It's 209 together. What is the probability that it's not red if you randomly select one? Alright, so it's either going to be white or blue. So add white or blue together, white and blue together, and then divide by 209. So it's going to be 114 divided by 209. If we round to 4 places, that's 0.5455. A marketing research company desires to know the mean consumption of milk per week among males over age 21. A sample of 574 males over age 21 was drawn with a mean milk consumption of 4.1 liters. Assume that the population standard deviation is known to be 1.1 liters. Construct a 95% confidence interval for the mean consumption of milk among males over age 21. Round your answer to 1 decimal place. Alright, so we got a lot of good information there. We're going to use. We have a sample of 574. We have a mean milk consumption of 4.1 liters. We have a population standard deviation of 1.1 liters. And we want to construct a 95% confidence interval for our critical value. So we'll need to get the critical number. Remember, there's a couple of ways to get the critical number. You can use the table, of course. That's the best way. There's this little mini table on this table. And it says for 95% confidence level, we have a critical value of 1.96. So what is our formula for our confidence interval? So what are we trying to make a confidence interval for? The mean, right? So it's going to be x bar plus or minus z sub alpha over 2 times sigma divided by the square root of n. So this mean was actually x bar, not a. So it's 4.1 plus or minus 1.96, we got from the table, times 1.1 divided by the square root of 574. So do that calculation, and you should get your lower number as 4.0 and your upper number as 4.2. Number 18, the which doors at a restaurant are example of which type of data. Width is going to be something you can measure, so it's going to be quantity. So that's quantity. The Education Commission wants to estimate the fraction of districts students at reading skills at or below 8th grade level. In earlier studies, the population proportion was estimated to be 0.2, so that's P. So from a population, how large would, how large a sample would be required in order to estimate the fraction of 10th graders being at or below the 8th grade level at the 98% confidence level with an error of at most 0.03. Alright, so we know on this problem T equals 0.2. We're at a 98% confidence level. We have an error of 0.03. Okay. So we want to know N, the sample size. So we need to use the formula to estimate the sample size. Let me grab my formula sheet. Chapter 10. So N is approximately V sub alpha over 2 squared times P times 1 minus P divided by the margin of error. So where do we get our critical value from? Table. Go to this little cheat sheet. You don't see it there. Okay, so that means we're going to have to calculate it. Well, I've shown in previous videos how to calculate 98%. And you actually get 2.33. Because at 2.33, the 98% would be 1 minus 0.98, which is 0.02, divided by 2 is 0.01. So there's 0.01 above this, and if you were to look up the negative 2.33, it would be actually 0.01. It'd be right there at it. So that's what we have to do. 0.0 for 0.01 we use 2.33. So 98%, you may want to write that down, you know, somewhere on your formula sheet for 98%. The critical value is 2.33. So the sample size, remember we always round these up. If we do get a decimal at the end, which we're about guaranteed to have one since we have all these decimals. 2.33 squared times 0.2 times 1 minus 0.2, so that's times 0.8, divided by the margin of error, 0.03 squared. 2.33 squared times 0.2 times 0.8 equals divided by 0.03 divided by 0.03. Alright, so here's my answer, and we want to round that up. So my answer is going to be 966. Don't just round it up. Put in that answer. Yes. the opera theater manager calculate 17% of the opera tickets for tonight's show have been sold. If the manager is accurate, what is the probability that the proportion of tickets sold in a sample of 494 tickets would be less than 15%? Round your answer to 4 decimal places. So this is going to be our P, going to be our P hat, or vice versa. Really, we want to know less than 15%, so this is going to be the first value in our z-score. So our z-score is going to be, what do we have to have? We have proportions. Remember, with proportions, you're going to need, usually we have x minus mu over sigma. Okay? So, with proportions, of course, some of these values change. So we'll have to figure out standard deviation. Probably, we have a sample number, so it's going to be like s divided by the square root of n here, and then we can find the difference in our two proportions. Alright, so for proportions, we have z equals p hat minus p over sigma sub p. And the sigma sub p hat is the square root of p 0.17 times 1 minus p over n. N in our problem was 494. Alright, so once we know this, we're golden. We're just going to say 0.15 minus 0.17 divided by whatever this number here is. Okay, so let me calculate that real quick. So it's 0.17 times 0.83 divided by 494. And then we want to take the square root of that. Alright, so I have 0.016900519. Alright, so we want to say 0.15 minus 0.17 divided by 0.01690519, and we get a z-score of negative 1.18. We round to 2 places. And our problem asked for, it wanted to know probability less than 15%. So less than is the area to the left, so we're going to actually just take the answer from the chart. So this is going to come from table B. So it's going to be to the left, means we take the answer, so negative 1.18, negative 1.18. Right here, 0.1190. 1190 is the probability that p hat is less than 0.15, 0.11. Study hard. Some questions if you have them.